Hey, Mr. Harridan here, and Darian. We're going to go over Dalton's Law over water here. Dalton's Law can be applied for problems where gas is collected over water. See, here's what happens. When usually you collect a gas, it bubbles through here, and it bubbles through here, it bubbles through, and it bubbles through water here, right? So the gas flows up here, flows around, flows around, flows around, and then makes little bubbles here, and then you collect the gas, because this is in the water, so this makes bubbles of gas, and you collect the gas over water. So this is actually the pressure of the gas and the pressure of water vapor as well. Okay? Which means you're not collecting the pure gas, you're collecting gas and the water vapor here, so then you have to subtract the pressure of water vapor here. So in other words, if you see an over water problem, you must subtract the water vapor pressure from the total pressure of the gas collected over water. So this pressure that we are going to get here is actually fake until we subtract it from the water. Now, how do you know the vapor pressure of water? Most of the time it's going to be listed in the problems here. Okay? Sometimes it's not listed in the problems here. There's a table on the back here of the water pressures at various temperatures. So you look up the temperature here, it tells you the water pressure, the vapor pressure of water, and then you subtract it out. Okay? So let's look at a problem of this here. Ready? 50 milliliters of hydrogen. So I know V is 50 milliliters. V1 is going to be 50 milliliters of hydrogen. Collected over water. Those are key words. Has a pressure of 850 torr. 850 torr. That means that this pressure is fake. And we cannot use that pressure. So, the pressure total equals the pressure of water plus the pressure of gas. The total pressure is going to be 850 torr. You can't see what I'm writing. P total equals P water plus P of gas. Okay? Total pressure is 850. That's the fake pressure. It says there's a hint here. The pressure of water is 26.7 torr at 27 degrees. So we're going to use 26.7 torr here. And then we're going to find the pressure of the gas. So I would subtract 850 minus 26.7. And I would have a pressure of gas of 823.3 torr. That's the pressure I can use. So that's going to be P1. It's going to be 823.3 torr at 27 degrees Celsius. You're right, Darian. We can't use Celsius. We're going to use 300 Kelvin. What would the volume of the dry gas be? So we're going to look for V2 at STP. Oh, you're right, Darian. Those are the sneaky numbers. Remember, that's 1 atmosphere and 0 degrees C. So this is torr. 1 atmosphere is equal to 760 torr. I'm going to use 760 torr. And the temperature at 0 degrees Celsius is really 273 Kelvin. P1 V1 over T1 equals P2 V2 over T2. Okay. Then we substitute in our numbers here. 123.3 torr times 50 milliliters over 300 Kelvin equals 760 torr V2 over 273 Kelvin. So you're going to end up multiplying these three numbers here. Then you're going to divide this number, and you're going to divide that number to solve this. And you end up with a V2 of 49.3 milliliters. This is using the combined with Dalton over water. Give you a second to look at that since I didn't show that on the screen for you. And I'll flip over to my next problem. Okay, page 13. A chemist collects 125 milliliters of oxygen gas. V1 is 125 milliliters of oxygen gas over water, and finds its pressure to be 1.24 atmospheres. That means that this is fake. So, and we have the pressure of water is 289.1 torr. So we're going to use P total equals the P of water plus the P of gas. Because this is the pressure of both the gases, not just the oxygen. That's why it's fake. Okay, so we're going to use 289.1 torr. I'm going to convert 1.24 atmospheres over to torr. One atmosphere on the bottom, 760 torrs on the top. Sweesh, sweesh. 760 times 1.24 is 942.4 torr. That's my total pressure. Equals the pressure of gas. Then you subtract and figure out the pressure of the gas is something. 942.4 minus 289.1. 653.3 torr. That's going to be my P1. 653.3 torr. And it is collected at 75 degrees Celsius. You're right, Darian. We cannot use 75 degrees Celsius. We can use 348 Kelvin, because you have to add 273. What would the volume, so we're going to be looking for V2, of the dry oxygen at STP? You're right, Darian. These sneaky numbers are back, which we are going to use 760 torr for this, because that's 1 atmosphere, and 273 Kelvin, because they're sneaky. Sneaky, sneaky. Sneaky, sneaky. So we're going to be looking for the volume in liters. We have P2 equals 760 torr, and T2 equals 273 Kelvin. So we're going to use the equation here. P1 V1 over T1 equals P2 V2 over T2. And then we're going to solve that problem there. Okay? So this is going to be 653.3 torr times 125 milliliters over 348 Kelvin, which equals 760 liters. Not liters, that's torr, Mr. Harrigan. V2 over 273 Kelvin. So here we are going to multiply these three numbers, again, because they're away from our variable. And then we're going to do a double divide. So we're going to divide by this number, and we're going to divide by that number. And we are going to get a V2, which is equal to 84.3 milliliters, which is the combined gas law with Dalton over water. Thanks, Darian. You were awesome in this video too. Okay, gonna let you guys go. You guys are champions. The legend is out.